In this study, we have developed an experimental setup which allows to follow the combustions of a single biomass particle. This makes it possible to follow the different steps of the particle decompositions under heat flux, mainly the drying, the pyrolysis and the flame period, and the char oxidations. The radiating heater consists of electrical resistance which deliver high heat flux to any object located inside. The pellet is sustained inside the radiating heater with the sun thermocouples located at the centers. The pellet and the thermocouple are put on a load cell, which make possible to follow the weight loss during the decompositions. And the temperature measurements are performed with the thermocouple located at the center. We can see that the main difference between the wood pellet and the oak piece is mainly on the density, which is lower for the oak piece. Here is the results for 3 pellets of the same length under the same flux. First, we have the drying period. After that, there is an ignition and a flame appear. At the end, we have flame extinctions and the beginning of char oxidation. However, we can see that the curve corresponding to the different tests are not superposed. There is some delay due to the initial time taken to introduce the pellet inside the heater. So the curve has been shifted in time in order to make their time of flame extinction superposed. And the result shows that now the curves are well superposed, indicating that we have a good reproducibility for the experimental set. The graph shows the mass loss and temperature for both wood and pellet sample. Each curve corresponds to an average over several tests. Obviously, we have the same behavior as a function of time for the pellet and oak wood, and it corresponds first to a short period of drying with a slow heating corresponding to conduction through the radial directions. At time 2, we have flame ignitions due to the release of volatile due to pyrolysis. After that, at time 3, we have a flame extinctions corresponding to the end of the emission of volatile, and also a faster heating, which is driven by the char oxidations. Finally, during the period 4, we have a slow decrease of the mass loss corresponding to the char oxidations and to a slow increase of the temperature. What can we say from the picture represented here is that pellet and wood piece show the same behavior, but all the phase, drying, pyrolysis, and char oxidation occur only for the wood sample. The elemental compositions cannot explain this difference. The only main difference between oak wood and pellet is their density. So this can explain the difference we observe and the timeline.